Okay, so before we begin, let's do a little refresher. What do you remember about coordinate geometry? So, first thing, can anybody tell me what is the general equation of a straight line? Anybody? The general equation of a straight line. What is the general format of it?
Mrs. Y equals mx plus c.
That's right. Y is equal to mx plus c. And what does m stand for and what does c stand for?
M is gradient and c is the y-intercept.
That's right. What is the y-intercept? What is the y-intercept? What does that tell us about the
The
graph?
y-intercept
Mhm.
is um the point where the line cuts on the y-axis.
Correct. The y-intercept is where the graph cuts the y-axis. Excellent. And the gradient, there's a formula to find the gradient, what it is. Anybody knows? How do we calculate the gradient given 2 points?
y2 minus y1 over x2 minus x1.
Excellent. Y2 minus Y1 over X2 minus X1, where Y2, X2, Y2 is 1 point and X1, Y1 is another point. So it's the difference of the Y coordinates divided by difference of the X coordinates. We say change in Y over change in X. Cool. Tell me something about the gradients. What is special about the gradients of parallel lines? Two lines that are parallel
The
to one another.
gradient is the same.
Good. The gradient is the same, so m is equal, right? For parallel lines. What about perpendicular lines? What about perpendicular lines? Lines that form a right angle with one another.
The product of the gradients is -1.
That's correct. The product of the gradients of perpendicular lines is -1. How do you find the midpoint of a line, guys? What's the formula to find the midpoint of a line? Anybody knows? Jazara, what's the formula to find the midpoint of a line?
Mrs. x2 minus x1 over 2 and y2 minus y1 over 3.
X2 minus X1 over 2. Isn't it plus? X1 plus X2?
X1 plus x2 and y1 plus
Yeah,
y2.
yeah, correct. It's plus Travis. Oh gosh, why am I calling you your name on the thing is not your correct name. Tristan. Yeah, so it's X1 plus X2 over 2 and Y1 plus Y2 over 2. So it's called the averages of the 2 points, the x coordinates of the two and the y coordinates of the 2 points. Tristan, the one that you might be talking about probably has to do with the length of a line. So like if I wanted to
Yeah,
find the
miss, I
length of
think
a line,
I
yeah,
mix it up.
it'll be the square root of x1 minus x2 all to be squared plus y1 minus, sorry, I wrote plus y1 minus y2 all to be squared, right? So those were some things that we learned about. Those are general things, and those are the main things that you need for your CSEC questions, right? So let's look at the first question here. It says a line JK has equation 2y is equal to 5x plus 6. Second, yeah, 2y is equal to 5x plus 6. Determine the gradient of JK. So, guys, this equation is not yet in the form y is equal to mx plus c. We can only read off the gradient from the equation of a line if it is in the form y is equal to mx plus c. Because this is 2y, we need to get rid of that 2 by, now you can't just remove it, right? If you just remove the 2 and leave it as y is equal to 5x plus 6, you're actually changing the equation. So what I will do is I will divide throughout. So the equation is 2y is equal to 5x plus 6. So to make y the subject of the formula, that is, the coefficient of y has to be 1, I will divide throughout by 2. So that would leave me with y is equal to 5 over 2x plus 6. And now this equation is in the form y is equal to mx plus c. Zayden, what is m and what is c? Now that we have expressed the equation in the form y is equal to mx plus c. Can you tell me what is m and what is c?
M is 5/2 and
Yeah,
C is 6.
that's right. So therefore, the gradient of jk would be what?
Uh,
Well, it's m, right? The gradient of the line is given by m. So in the equation of a line y is equal to mx plus c, the reason we wrote the equation in the form y is equal to mx plus c is so that we could easily identify what m is and what c is, where m is the gradient and c is the y-intercept. So the
Yes.
gradient of jk is therefore equal to 5 over 2. Did somebody call me?
Yes, and y and is also supposed to be 3? Or does it mean it 6?
Oh my gosh, you are correct. It is 3. Yeah, absolutely. Tell us why fired. You are so correct.
Because the 2y is like multiplication, so when you jump it across because then it becomes division.
Okay, well, we didn't jump it anywhere. We
Well,
divided
let's move it
throughout.
across. Yeah, like it's divided by 2 and give it a c.
Yeah, so we didn't technically move 2 across the equation because if you move 2 across the equation, then you would only do it to one thing, right? But so what we did is we divided throughout by the coefficient of y, right? Um, Now, I think nothing is wrong with saying that you transpose a term from one term to the other, from one side, sorry, to the other side of the equation. But a term, really, like when you move it from one side to the other side of the equation, you'll think about it more like if you're moving like 6 from the right-hand side to the left-hand side, it'll just become minus 6, right? But when you're looking at division and multiplication like this, it's better to just think of it in terms of dividing throughout or multiplying throughout, right? Or even if it was like a single term on both sides of the equations, like if you said 2y is equal to 6, for instance. Well, here with transposition, if you're not wrong, eh? I'm just like explaining this a little further. If you have 2y is equal to 6, it might be more acceptable to say, well, we move 2 from the left-hand side to the right-hand side. So instead of multiplication, we divided, right? But it's just more acceptable here because it's to say it like that because it's just one term here, right? So yes, the Fayed is absolutely right. I don't know how come nobody else spotted that mistake, including myself, but yeah, we divided throughout by 3, so we'll get 5 over, sorry, divide throughout by 2, so 5 divided by 2, I leave it as a fraction. The reason I left it as a fraction is because I prefer to work in fractions, especially with coordinate geometry, when you have to do a part that says a line is perpendicular to it, because it's much easier to flip 5 over 2 and make it negative than 2.5. To find the inverse of 2.5 is not as straightforward as finding the inverse of 5 over 2, even though it's going to be the same answer. All right, so yes, the gradient of jk is 5 over 2. And now the next part of the question says another line GH is perpendicular to JK and passes through the point 5, negative 1. So the first question says state the gradient of the line GH. And of course, that's only 1 mark. And the reason that it's only 1 mark is because you practically found it already. Remember that the gradient of perpendicular lines, the products of their gradients is negative 1, or that they have negative reciprocal gradients, right? So the answer would be since GH is perpendicular to jk, its gradient is, what is its gradient? What would be the gradient of jk? I mean gh, since it's perpendicular to jk. Anybody knows? Remember, we just found the gradient of, yeah, sorry, tell me.
Negative 2/5.
Negative 2/5, that's correct. Why is it negative 2/5? You are right.
Because perpendicular lines have a negative reciprocal.
That's
to
right.
unit.
Correct, because perpendicular lines have negative reciprocal gradients, as well as the product of their gradients is -1. So therefore, if the gradient of jk is 5/2, then a line that's perpendicular to jk will be -2/5. All right. So guys, pay attention to your mark scheme too, right? The first part says it's 2 marks. You're gonna get 1 mark for here. You're going to get 1 mark for writing over the equation in the form y is equal to mx plus c, and you're going to get 1 mark for correctly identifying that m is 5/2, right? Good. The next question says determine the equation of the line GH. Now remember, to determine the equation of a line, all you need is the gradient and a point on that line, which we already have. We have that the gradient is -2/5 and a point on the line is 5, -1. It says that the line GH passes through the point 5, -1. So what we're going to do now is we're going to use that point, right? So substitute the point 5, -1, and m is equal to -2/5 into y is equal to mx plus c to find out what c is. All right, so let's do that. So y would be -1. M is -2/5. X is 5, and then, well, C is what we're trying to find out. So we'll have -1 is equal to -2/5 times 5, 5 into 5, 1, 5 into 5, 1. So this will just be -2 plus C, and therefore C would be equal to -1. So here, -2. So when you move it to the other side or we transpose, it will become +2. And therefore C is equal to 1. So we rewrite the equation, replacing M and C. Therefore, the equation of GH is y is equal to -2/5x plus 1. All right, guys? And that is your, how many? 5 marks. 5 marks. All right, 5, I think 5 pretty easy marks to get. Everybody's with me? Zaydan, how are we going there?
Goodness.
All right, Evan, is it all right? Following?
Yeah, mister.
All right. Well, fired. I'm pretty sure you're following. All right. Jazara, yeah, you already spoke to me. And Tristan. Tristan, how's it? Good?
Yeah, it's good.
Okay. Wonderful. Let's do another one. So this is May 2016. The diagram below shows the diagram below shows the graph of the straight line x plus y is equal to 3. Parallel to the line, determine the equation of the line which is parallel to the line x plus y is equal to 3 and passes through the origin. Okay. So let's see. First of all, we need to determine the equation of any line, we need to find out what the gradient is, and we need a point on the line. Now, it tells us that the line is parallel to x plus y is equal to 3 and it passes through the origin. Guys, what is the equation? What is the coordinates of the origin? Y'all know what is the coordinates of the origin?
0, 0.
Yes, 0, 0, right? So this line is going to pass through the point 0, 0, and it's parallel to the line x plus y is equal to 3. So Tristan, if it's parallel to the line x, this line here, what does that tell us about it? Any interest in anything it tells us? Anything that we could take and use?
Yeah, miss, the gradient will be the same.
No, not the same. You're correct. Sorry, I'm so sorry. I don't know. You said parallel, and I thought perpendicular. No, perpendicular is part two.
Yes.
Yes, correct. The gradient will be the same. So how would we determine the gradient then? So if it's parallel and passing through the origin, it means it's gonna look like something like this, right? This is gonna be the line passing through the origin, 0, 0, and it's gonna have the same gradient since it's parallel, correct? Well, how would we find out the gradient then? Of the line, this line with AB. Anybody knows or want to try? How might we find out the gradient?
You gotta get the 2 points.
Yeah, you take 2 points on the graph. Yeah, so tell me, you're going to use A and B as the 2 points?
Yeah.
Sure. What's the coordinates of A?
0, 3,
Mm-hmm.
and the coordinates should be C 0.
Correct. Good. So we can use that, right? We can use that for the to find out the gradient. But you know what else we could do? Fired. We could also just rearrange the equation x plus y is equal to 3 in the form y is equal to mx plus c, and we could just read off what m would be. Not so? So there are two ways you could do it.
Yeah.
You could for sure take the 2 points and then use the formula, but you can also just rearrange x plus y is equal to 3. So help me rearrange it now. X plus y is equal to 3. I
Your
want
Vy is
my,
equal to Tx.
it'll be y is equal to 3 take away x. Because this is
Oh,
y plus x on the left-hand side, right? So when you
yeah.
move plus x to the right-hand side, it'll become minus x. So what's the coefficient of x here?
See?
No, it's minus
Negative x.
x, negative 1.
Um,
Right? So M in this case is, you remember when you don't have a number directly in front of X, it's just 1, right? The coefficient of it is 1. So in this case, M is negative 1. And C, what is C? Alright, what is C
see?
in this equation? It's 3. Yeah. Right? You know, it would probably even help to write it even, hold on, let's make this a little bigger. Yeah, it may help to write it as, oops, sorry guys. Yeah, as where you put y is equal to negative x plus 3. And that's exactly in the form y, mx plus c. So m here is negative 1 and c is 3. So the gradient of that line is negative 1, which means that the gradient of a line a line parallel to it will also be negative 1. Right? And we know that that line passes through the origin. So, Tristan, what will we do to determine the equation of the line if we know its gradient is negative 1 and it passes through the origin? Any clue?
You would have to use y is equal to mx plus c.
Mhm. So we'll
And
substitute, yeah,
yeah, and put in the gradient and
and the
wait, to see
origin.
gradient.
Well, the
Oh,
gradient for this one would be -1, because remember, you told me that it's parallel, right? It's parallel to this line, and because it's parallel, they'll have the same gradients. So we just determined that the gradient of this line is -1. So therefore, the gradient of this line in question is also -1. So we're going to substitute that m is equal to -1, and the point that it passes through was the coordinates of the points that it is passing through.
0, 0.
Good. And we're going to substitute 0, 0 into y is equal to mx plus c. Yeah. So that means y is 0, m is -1, and x is also 0. So c would just be 0, right? Because -1 times 0 is 0. So therefore, c is equal to 0. Therefore, the equation of this line will just be y is equal to -x. And that is a line that you all should learn off by heart, by the way. Use it, and because you're doing transformations, you should learn. I mean, all of you would have to learn it anyway, right? Because you all are doing, you will do transformations, and there can be a question that reflects a line or reflects something in the line y is equal to -x. This is the line y is equal to -x. This line that I just drew here, this is the line y is equal to -x. Another line that you would need to be familiar with is the line y is equal to x. So it's also a line that passes through the origin, but of course it's going to go this way because it's positive x, right? Because remember, if you have y is equal to x, the gradient of this m would be +1. So you would expect a line that is increasing from left to right. For the line y is equal to -x, that's going to be a line decreasing from left to right. This blue line here, right? That's the line y is equal to -x. So you have to get familiar with those two lines. All right, because in transformations, it's important. Something can be reflected in the line y is equal to x or y is equal to -x. And what you would notice, now remember, the equation of a line gives us the relationship between the x and y coordinates on that line. So if we look at the line y is equal to x, right? Every single point on that line, literally y is equal to x, meaning the y coordinate is the same as the x coordinate. So you see, this point that I just drew here, the coordinates of that point is 3, 3. So y is equal to x. Here, it's 4, 4, right? 0, 0, -2, -2, -3, -3, etc. For the line y is equal to -x, well, let's look at it. If I put this point here, well, x is -3, and the coordinates of y here is +3, and that is negative x, right? Because x is -3, so -3 would be +3. And so it will go for all the points on that line. Look, here, this point here is 1, -1. So y, which is -1, is equal to -x because x here is 1 and y is -1. So the relationship between the equation of a line tells us the relationship between the x and y coordinates. All right, so please make a note, get familiar with the the line y is equal to x and y is equal to -x. All right, so the next part of the question tells us to determine the equation of the line that determine the equation of the line which is perpendicular to the line x plus y is equal to 3 and passes through the midpoint of AB. Okay, so midpoint of AB, now we're gonna have to use those coordinates for sure. Somebody remind me, how do we calculate the midpoint? What's the formula to calculate the midpoint? Jazara, can you remind us of it? I think you told us at the beginning of class when we were recalling the different things. How do you find the midpoint?
x1 plus x2 over 2 and y1 plus y2 over 2.
Right. So this would be the 2 points that we're looking at 0, 3, and 3, 0. Yeah, so that would be, well, x1 is 3 and x2 is 0. And then y1 is 0 and y2 is 3. So the coordinates of the midpoint there will be 1.5 and 1.5. But again, I'm going to use fractions. So 3 over 2 and 3 over 2. And that makes sense. Like if we look here, 3 over 2 would be, well, 1.5, right? And 1.5 would be here. And that is the midpoint of AB, right? That's directly in the middle of A and B, the halfway point of A and B. Good. So this line is perpendicular to AB and passes through that point. So you're gonna expect something kind of like this. So let's see. And that's just not drawn to scale or anything. So that's not an accurate diagram, but let's see. So also, if that line is perpendicular to AB, we already know that the gradient of AB is -1. So the gradient of this new line that we're figuring out would be +1. All right. And it passes through this point. So like we've been doing all along, all we need to do is substitute this point, 3, 2, and 3, 2, and the gradient 1 into y is equal to mx plus c. So substitute 3 over 2, 3 over 2, and m is equal to 1 into y is equal to mx plus c to find out what c is. So that would be 3 over 2 is equal to 1 times 3 over 2 plus c. And therefore, well, this will just be 3 over 2. So you'll end up with 3 over 2. Take away 3 over 2 is equal to c. So therefore, c is equal to 0. All right. And so the equation of this line would be y is equal to x, which I already showed you all, right? So the equation of the line would be y is equal to x. Right? Once the two coordinates are the same, guys, and the gradient is 1, that is the line y is equal to mx plus, sorry, that is the line y is equal to x, right? This is the line y is equal to x. So that line is perpendicular to the line AB. And then the other line was y is equal to negative x. It's basically the same line, except it passes through the origin and it's going in this direction instead. All right. Did I do the whole question here? Okay. Right, let's look at this one, Jan 2017. Okay, I want you guys to work this question out for me. The perpendicular bisector is a line that passes through the midpoint and forms a perpendicular angle. So it's so like for example, if you have the line AB like this, right? And let's say this is the midpoint, the perpendicular bisector will pass through like that and make a right angle, right? So I want you all to try this question for me. Take a few minutes and try it. Good. So it says P 6, -1 and Q with coordinates 2, 7 are the endpoints of a line segment PQ. Determine part 1, the gradient of PQ. So recall that the gradient M is equal to change in y2 minus y1 over x2 minus x1, right? So that would be -1 take away 7. That's the y coordinates of P minus the y coordinates of Q over the x coordinates of P, 6, take away the x coordinates of Q. So this would give me -1 take away 7 is -8, and 6 take away 2 is 4. -8 divided by 4 is -2. So the gradient of PQ is equal to -2. Next, we need to find the coordinates of the midpoint. The coordinates of the midpoint, capital M to represent midpoint, is found by adding the x coordinates. So it's the average of the x coordinates of the endpoints, right? The x coordinates of the endpoints, and the average of the y coordinates of the endpoints. So x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So this would be x1 plus x2 would be 6 plus 2 over 2, and then -1 plus 7 over 2. So guys, this will give me 8 over 2, because 6 plus 2 is 8, and -1 plus 7 is +6 over 2. Therefore, the coordinates of the midpoint will be 8 divided by 2, which is 4, and 6 divided by 2, which is 3. All right, so the coordinates of the midpoints are 4, 3. And now finally, the equation of the perpendicular bisector of PQ. So remember, if this line is perpendicular to PQ, it means the gradient is the negative reciprocal of -2, right? So the gradient of the perpendicular bisector, gradient of perpendicular bisector would be, now -2 is really -2 over 1, right? So when you invert that or you take the reciprocal, it'll be +1 over 2. And now that we have the gradient and we have, well, if it's the perpendicular bisector, it means that it passes through the midpoint of PQ, right? So the perpendicular bisector passes through the midpoint of PQ. All right, so that is a line, sorry, a point on the line. Now we have a point on the line and we have the gradient, so we can find the equation on the line by substituting m is equal to 1/2 and the point 4, 3 into y is equal to mx plus c. And that would give us, well, y here is 3. 3 is equal to m, which is 1/2, times x, which is 4, plus c. So therefore, 3 is equal to, well, 1/2 of 4 is 2. So 3 is equal to 2 plus c, and therefore 3 minus 2 is equal to c. So c is equal to 1. So therefore, the equation of the perpendicular bisector would be y is equal to 1/2 m plus, sorry, not 1/2 m, sorry, 1/2 x. 1/2 x plus c, which is 1. And that's the answer. right? So some of the mistakes that I observed from you guys is, well, this part you all forgot, you didn't invert properly. So if the gradient of the line P, was it PQ? Yeah, PQ is -2, then the gradient of a line that's perpendicular to it will be the negative reciprocal of -2, and that is a half. The midpoint, some of y'all just made a little mistake with the calculation, so be careful with that. But the midpoint is 4, 3. And once you have the gradient and the midpoint, you can find the equation of the perpendicular bisector as you would for any equation of any line by substituting the gradient and that point into y is equal to mx plus c.